Hello, hello, testing, testing. Um, let's see if everything is working fine. Let's see if everything is working fine. Well, so far is well. Well, welcome everybody or anybody that joined. I'm not expecting people to participate online. I know it take a while until any YouTube content really pick up and get videos. So the idea is this is a volunteer project that I do have, and we're gonna be learning coding. Uh, I changed my plans a little bit. Initially, I was supposed to use Kotlin as the program language, but I had some talk with some friends, and I decided to use Python. And there is multiple reasons. The two main one is Python now today is the most used language. So if I'm trying to help as much as people I want, I can. Python is a good option. The second one is this. Python is one of the simplest and most like beginner friendly language. So is that why like using Python is a good idea. Cool. So I put advertising the LinkedIn there. I said that I will be teaching Kotlin. So sorry if you came expecting for Kotlin, but I guess Kotlin is a very cool and good language. My company use it, but I think it's not a good choice for a first language. So let's start with Python. It's awesome. It's easier to learn, and later on we can think about learn some different like language. Let me just test something here that make sure that the channel is really working. So give me a second. I'm in doubt that sometimes YouTube does not work the way that it should. Let me go here. My channel. Let's see how it works. Let me go. Oh, it's good. My channel. Okay, it's working fine. Okay, so let's go. This is just some overview. I was a professor for a long time, and I always like to, in the first class, to have a real talk and explain some details about it, the course or the discipline or the training we have, and then some open eyes. So let's go. Here is my goal is to empower every person to be able to code. So I love my career. I'm 52 years old and so far have been like doing very well. I hope continue that way, knock on the wood. And I feel the need to share some, to give back to society and to the universe something that was make my life very good and easy. So that is one of my main goals, is to empower everyone to be a computer programmer. The material is going to be prepared on the go. So I don't have everything. I have most of the thing prepared, but I'm going to organize. So right now I'm going to show where I'm publishing material. So it's going to grow as we go. Okay. My focus is to have like a light material, focus on demonstration and practice. So I'm not going to be too focused on theory, concept, and like I'm gonna prepare for real life situations. So I'm bringing here my life experience, my professional experience, focus on what is most important, what someone really need to know to be ready to go to the market. Okay, so this project is aimed to be like a live book. So instead of just go there and read, you're gonna watch, and of course you have to do some practice and do some exercise. Oh, I forgot to change this. So it's not just a Python course. I'm not focused on teach you Python. I'm using Python as a tool to teach you like the basic concept that most of program language you have. So Python is the less important thing here. Of course, it's a cool language, we make it easier to learn. But the idea is to really go in the fundamentals, okay? So we're gonna be focused on software engineer basic concepts, overviews. a lot of topics I'm gonna just talk a little bit and then show. Other ones I'm gonna be more like going deep because it's important to help you understand and retain. And I will bring some tips in our area as well. So tips about interviewing, tips about how to do best practice, how to do some of the work. So my goal is to really support you to learn coding and become a professional. I'm very pragmatic. I believe that is better when we are like talking or teaching or preaching or doing anything about what we really do. I don't feel confident to come here and talk about something that is not my reality. So everything I bring here is something that I use in my professional life and worked for me, and I believe it's going to work for you as well. So we'll be focused on fundamentals and essential concepts, but everything you're going to learn here is useful. We're not going to waste any time learn stuff that is not really needed. That is the catch. Compared to the other areas like law, medicine, even engineer, computer science has a very, the fundamentals is not that vast. We can make a good software engineer in like 2 years, 3 years is good. We cannot do the same with a doctor, with a lawyer, because the amount of knowledge and then all the certification probing that they have to go through is different from us. So in our training is very cheap because we, of course, it's not free because you need access to a computer. We have to have the power, but we don't need to have a patient. We don't have to have a client, or we don't need to have real life materials to build something. Software is like a service. We can have an ideas and we can play with those ideas. If it doesn't work, we just delete and do again. Okay, so that is a nice thing. It's like we are like an artisan that we don't really to use like real clay or any wood. It's just an ideas and coding. I will skip some complex and not so common features. So there is a lot of difficult thing that is very rare to be used. And I'm gonna just pass through. Maybe I'll just mention so you have an idea. If you like, you can go deep. I'll give some direction where to go to learn more details about the topics that you're gonna be seeing here. So of course it's not easy, but I'll simplify as much as possible. However, think with me, there is nothing in life that really works that is not hard, that we don't have to put our effort, our attention, our focus on it. So I will urge you to do the same here. I will do my best to bring you like high quality content. My goal is that this training will be up to the same level as any good like college or university degree. And you need to do your part as well. You need to really pay attention, maybe participate and do some questions and do exercise. You're going to have a lot of things to do. So there is no point for just me to doing all this and then you are there not doing your part as well. So it's very important that you focus and do reviews and do the practice. We only get good at anything when we start to do it, play it. So we're gonna have a lot of practice, like a lot of time here. We're gonna be solving problems, and then I'm gonna be help you try to find some solution, and I will solve it. Because in the beginning we have to build up that tool set, so you're gonna be able to solve new problems. We're gonna have exercise and homework as well, and I like to use this analogy with a gym. So imagine that you want to become like stronger or a better shape, and you join the best gym in town. You pay the prime like membership. You hire like a personal trainer, and you just go there and you sit. You just walk around and you don't do what is required to really get in shape. So it's the same. You need to do your part as well. be ready to jump in, do exercise, pay attention. I'm not doing this to gain views. A lot of people told me, oh, you have to do shorter class, 20 minutes, 50 minutes, and then you get more. I want to give you the same experience as someone that is paying a lot to go to a university. And they have 1 hour, 2 hours lecture or class. So it's the same here. You need to have patience and dedication. If not, okay, this is not for you. Some of the course details. So first there is a URL. So I have this URL here. If you open it, we will land in this GitHub page. Oh, came to the wrong one. I will fix that, but is this one here? Sorry. Oh, code. Okay, now it's like we'll learn what GitHub is, how to deal with it. But right now, imagine that is a home page or a website where you can see the content that I'm publishing. So this is the README page that you can read. It's kind of a little bit about this training, some of URLs, there is something about me, and this is the entire course content. So now is what we have, what you learn. So C is a lot of things. Now a lot of them make no sense to any of you, but soon we're gonna learn all about this. Okay? And I will be posting every class. I will save the recording and I will point all the files that you use here. So you will be able to later on come and see all the content and rewatch, access the files that I'm creating. There is oh, and of course in here, let me go all the way up. I forgot to mention that this is the YouTube playlist. So if you go here, you see the playlist where I will be adding those videos. So this is the first one I'm gonna add here, and then we're gonna have multiple videos there. We will have multiple videos there. Oh, come on, I fixed this already. So our class will be every Tuesday and Thursday, 8 p.m. If I see that people is joining, I will try to keep the same time, but if not, it's fine, because I know that not everyone can really commit to a fixed time, but the videos will be there and you can watch wherever you want. I already have another train that is happening, so most of the views are not live, but I do live just to force myself to really concentrate and focus on the content, because I feel like I'm in the classroom. And if I'm just recording, maybe I do something silly and I have to go back or fix. And now at least I'm feeling that I'm talking directly to you. We use Python as the programming language, like I said, but the focus here, we're going to learn a lot about Python, but the focus is to use Python to learn all the fundamentals. And like I said, oh, this we are kind of repeat what I already said. I guess oh, just to show you that this is a serious thing, I already have an ongoing training similar to this one, where all the text is in English, but I speak in Portuguese because I am target the Brazilian folks. Is where I'm from, and is the people that I want to help first. But now I'm open to everyone that can speak English. This is the playlist. So this codando is like is a silly word in Portuguese that means like coding. So if you go there, just to show you, we have plenty of class. So this project started like 1 year ago. And if we go all the way to the end, you can see that we do have like more than 200 class, 204, I think. So 205 is just to give you some confidence that this is not something that's going to start today and end tomorrow. It's something that I really dedicate to it. It's like people go to church, people do donation. This is what I do to feel good. Okay, I'm bring here all I know, and I'm trying to transfer to you for free. And this is the repository. So this is the one for our current training. This is for the one that material I already have. So if I go here to, for example, C#, you can see there is a lot of stuff there. So it's 1 year of training. So right now we are learning like data structure. So the last class was about this thing here, like graph, and here's all the implementation. So 1 year from now, if you keep it, or maybe shorter, you're going to be able to understand and do all this. Okay, we have to be patient, and there is dedication. Not going to be a program like 2 or 3 weeks. That is not possible. It's like to become a doctor in 1 year, 6 months. It's not possible. So I'm going to be realistic. You have to invest your time, and in the future, you're going to become and be able to fight or go to those great jobs we have now. Whoa, so this I'm using C# in this training, this Portuguese training. Like if we go there just to have a little bit of fun, if we click here, you see that I'm speaking Portuguese. Tá? Deixa eu primeiro aqui ver se está tudo funcionando bem. And as you can see,
a aula de hoje é bem interessante.
Let me put
então vamos lá. Hoje a gente vai continuar.
Volume very low or even good. I'm very visual and I'm trying to show everything I'm doing. So I will do the same here. I think visualization helps a lot. I go very slowly, and like in Portuguese, I tend to speak faster. I'm very faster speaking Portuguese, but English is my second language, so I'm slower. So that is good. I even be slower in those classes. Okay. So it's just to show you that I already have a project like this one in Portuguese that is going on for good time already. Okay. Okay, let's now start to talk about, I would say, computer programming things. The first thing we're going to talk about is the thing called application layers, because it's a very basic topic and it's important as to understand. So nowadays we can separate our layers in, oh wait, something is wrong here. This guy is the same as the other ones. Oops. No, let's keep this way. So every application, every software, there is some important layers. The first one is called user interface. So this is how we interact with our clients, with our customers. So I put some pictures here that most of you can identify what type of user interface is that. So we call user interface or front end. Let me just try this here. This guy has to go left, more left. This guy has to go left. And those ones has to go right. Sorry for that. Let me just correct this. And this one I will copy the style and put here. Didn't work. So this one goes there as well. Uh-oh, something is not working fine. Okay. So usually the layers that we have is, let's say, front end or user interface. So that is what we expose to the client to interact with our application. So every system nowadays has to interact with someone. So console is that old school thing that is like we say is text mode, like text based. So if I open my console here, like I'm using Linux, this is Linux. So this is what we say that is a console application. So everything here is text-based. So if I want to see something, I have to do something like this, and I can see the result. I can clear. I can run some commands like this one that show information about my system. But see, that is a very poor and basic UI interface. So this is how everything started. Initially, every application, like 30 years ago, 4 years ago, this is only we had. Every interaction with a computer was based on a terminal that was a console. But things involved, and then we have the desktop. Back in the days, we start to have like a program like this one. See, I'm using this guy, OBS Studio, to record our class. And this is a desktop application. As you can see, is way more elaborated and is not just text-based. Like we have image, we have buttons, we have like a lot of different controls that you can use. And with the advance of technology, we have some new user interface layers. So one is the mobile that everyone knows a lot. It's kind of, if I show you a picture, you're gonna identify right away that is a front end or is a mobile one. And then there is the web that I don't need to say anything. Okay, so what I'm trying to explain you is that, like engineer, when we think about a house, we have the foundation, we have the structure, we have the roof, we have appliances. So I'm trying to explain that usually in software we have like those three important layers. The first one is UI or front end. In this front end we have all those four basic ones: console, desktop, mobile, and web. So in our area, it's like in medicine, someone say, oh, I'm gonna be a geriatric, or I will be a surgeon, or I will be a eye doctor. So it's kind of different skills, different knowledge, and it's very hard for someone to really be good in everything. You can be in two of them, maybe three, but to be on top of all four is very, very difficult. So it's the same. Usually we're gonna pick up one of this line, or sometimes the area choose us. We find a job to work in the desktop application. We'll dive deep and learn about it. We can be a mobile developer, a web developer. Console is more like tools, so no one is really a console application developer, but it's something that we use. So in this training, most of the time we will be using console because it's the simplest one and you can use to interact and build our code. Give me just a second here. However, the user interface has the one job. This is more than one job, but it's basically interact with the end user. Is that what I call user interface? Interface with the final user. So basically what we have to do, prepare data, collect input from the user, and give some results. But we know that all this information, not all, but most of the information now has to come or has to go to some other place. So this is where you call the server side. So here is a Google Map application. So to know where I am or to show the map, I need to get this information from a server. If I'm type something here to get the best route for one place, I need to talk to a server. So that is this server layer. So we'll see later on. We're going to learn a little bit about those things. But the server side basically is this. All the coding that we do in the server side that we can support our user interface. So the job work interface is to interact with our user and then send and retrieve data from the server side. Once the server side has to do the work, it has to save and read data from one persistent place. So that is the data layer. So I'm just to give you some overview. We are like in the basic here, but it's just to understand, when I talk about software or application has layers. So The first one is interface, that interact with the user. So here's the interface. I'm clicking buttons and move stuff, but this is our application. So there is a server side that is getting all the requests here. So when I save the file, I create a new file. Here there is an auto saving. I not even click the button save, but as I'm using like a browser for that, it's save automatically. And I can turn off my PC, come back later on, and my data, my file will be there. So we have to persist this data. So basically it's interface with the user, logic to deal with the user request, locate data, save data, and this is where the data is being saved. So we can persist it, the user can come back later on, and we can retrieve the data. Okay? Another very basic and important process definition is about the data processing model. So most of the application, or most of the interaction, we have an input. In this input, we call data, because look this way. A computer is a special machine that instead of deal with like real things, deal with data. Computer come from that. So what a computer does is we process data. Instead of we have like a tool that we can build something, break something, or like change something, we're gonna be changing data. So most of the programs is gonna have an input that is data that we're gonna provide to that program. The program will do some processing, will be the transformation. It's like we are doing a recipe to bake a cake. The input is all the basic ingredients. The processing is we are putting those ingredients together, doing something. And then there is an output. The output is the final product. And in this case, for us, we call information, because we got the raw data, we did some processing, and then we return what the user needs. So most of the thing here is the UI is going to get the input. The server side will do the processing, and then there is an output to data and back to the user interface. So this is just a model, because every problem that we're gonna solve here, I will start this way. What is the input? What is the output? And we have to figure out what is the processing. What operations we need to do in data to transform it to our information. So it's like to baking a cake. We have the ingredients, and then we have the cake at the end. Computer is a special machine that what we process is information, is data. We process information to create, we process data to create information. Okay, it's a very simple concept, but as we're going to be using it, input, output, you already know. Input is data going into, to a computer. Output is we giving back data to whoever needs that data. Another two very important concepts here is algorithm and a program. A lot of time they are used as synonymous, like they think they are the same. A lot of people sometimes confuse, but by definition, an algorithm is a step-by-step procedure or a set of rules to solve a specific problem or accomplish a certain task in computing. So that is the basic idea. We have a recipe to solve something. However, this recipe is in a high-level language because it's designed for human to read. We don't have still a lot of details that is required to have a program. It is like a recipe that describes the exact steps needed for a computer to solve a problem or reach a goal. So I would say that algorithm is like a the essence about how we solve a problem. What are the steps or the ideas that we need to follow to solve something? How to calculate an average, how to identify if I qualify for a mortgage. There is a logic behind it, so there is an algorithm for it. Now let's talk about a program. A program is an implementation of an algorithm. There is an idea how to solve something. So a program is also known as software, and is a set of instructions written in a programming language. So algorithm, we can use drawing, we can use like plain text, English or any language or whatever. We just need to be able to explain the steps to solve something. For example, when you buy something for IKEA, or you buy something that you need to assemble, there is an algorithm there that you have to follow to put the parts together and have the final product. It's the same idea. A program is different. It's an implementation of an algorithm. So a program is written in a programming language. In a programming language, you have to follow all the details and rules of that programming language, because algorithm was created for a human to read. So we have a lot of space for like some dubious thing that we can like guess what is the best solution. When you make a program, a computer cannot guess anything. It's going to follow exactly, strictly what we are telling it to do. So a programming language has to be exactly in a way that that language was designed to be, and explain to a computer how to do something. In essence, a program tells the computer what to do and how to do it. Another concept is that a program has to be translated before it can be executed. So all the programs that we talk about, they are written in a programming language. And even not being like plain English, is a language that is more formal. Someone has to create that language and has to build software to translate that program into something that computer can execute. Because at the end of the day, a computer can only execute machine code, machine language. So we'll be learning here like Python, that is a program. We're going to create a program source, and then we have somehow compile or interpret. Interpreter. Right now, this is not too relevant, but what is important us to know is we'll be writing a program in a programming language, in this case Python, and someone builds tools that will translate that program to code that the machine can execute. So we have to be very thankful for the people that work on this. So whoever created Python had to build some tools to allow us to translate Python instruction to code that the machine can execute. Okay, we'll see that later on, but for most of us, that is kind of an abstraction. Sometimes we don't pay attention, but what is being executed is not the program that we created. It's something else that was generated from our program. But as this is automatic, we don't care too much. We just need to learn this higher level language. We will see some example. And now we will have some interesting to do. So, with that in mind, we'll see here an example from an algorithm. So this algorithm tells us finding the maximum number in a list. So we are teaching someone how to, given a list of numbers, how we find the maximum number in that list. Let's read and let's see what happened. We say, okay, the algorithm is set the maximum for the first number in the list. For each number in the list, if the current number is greater than the maximum, update the maximum with the current number. Imagine that this is our list. The maximum is the largest number in this list. Oh, let's execute this algorithm. What the algorithm tells us to do is, okay, set the maximum to the first number in the list. So imagine that, let me give the full name here, maximum. With the first number in the list, let's say 50. Okay, we are with this number here. For each number in the list, that means anyone that is reading this is going to say, okay, I have to go to each number. Imagine that now I'm 30. If the current number is greater than maximum, update the maximum with the current number. So 30 is greater than 50? No. Observe that it tells us for each. So we can conclude, okay, I will move to the next. 10 is greater than maximum? No. I move to the next. 50 is greater than 55 is greater than 50? Yes. So then we update this maximum. We go to the next one. 15 is greater than 55? No. We do nothing. Our instruction is we only go update if maximum is greater, if the number, the current number is greater than maximum. We go to the next one, 80. 80 is greater than 55? Yes. So then update the maximum with 80. We go to 75. 75 is greater than 80? No. 35 is greater than 80? No. 40 is greater? No. 9 is greater? Yes. 15 is greater? No. 10 is greater? No. So that means after you go through the entire list, at the end, we have the maximum. So this is an algorithm because it was created for us, human, to read. So we don't need to be too formal. As long as we can explain the operation and pay attention to one thing. In algorithm, we have like a lot of different ways to write this. You could say here, save the maximum number. I say go through each number, replace maximum if the current number is greater than. So we have a lot of flexibility here because we are dealing with another human being. So we know that the human being can really understand it. And now we can say, okay, then we have the result. What you see now is some example of the same algorithm as a program in some different programming language. So let's go here. The first language you see is Python. So in Python, what we do, we have this list, the same list we had there, and then I say, okay, print find maximum, pass this number. What this find maximum does, save the first number, 50. Then there is like a command that make something be each one of those values. For each one of those values, we're going to test if num, that will be each one of those, is greater than the maximum, update maximum. When you go through all this list, return maximum. We'll be learning this in Python. So this is one of exercise you do. And as you can see, it's not that hard because we are telling the computer, okay, do you know? Save the first number. Now loop through all the numbers. For each number, test if it's greater than the maximum. If it's true, save the maximum as the number because now I found a bigger one. This is the code for Python. Python is I say the easiest language, the one that is easy to understand, easy to write. Now Kotlin. Kotlin, you can see that there is some different here. We have this var word here. The for is very similar, but there is this parenthesis here. And do you see that in Python we have those columns here, here, and here? In Kotlin we don't have, because whoever create Python define those rules. Whoever create Kotlin define those rules. You see here that in here we have only numbers. Here I had to say number is a list of integers. I don't need to tell what is the return type. I could, but I don't need to tell that in Python, what is return type. But in Kotlin I need to tell. This guy is going to return a number. Another detail, a list of numbers in Python is just open and close brackets with the numbers. In Kotlin is something different. I have to be list of and then put the numbers. So boils down that when we really learn algorithm, to translate that to a program language is just about to know details about that language. Is that why I'm trying to tell that the language itself is not the most relevant thing we will learn here, is the concept, because we will be learning how to be able to break down a solution for a problem in a way that a program language can execute it. And after that, when we have this program here, we're going to use tools that will translate this program in machine code that a computer can execute. Okay? Now we have C# and Java. It's basically the same idea. There is some different, but Java and C# they are very similar. Do you see here? The first line is the same. The second line is pretty much the same. Third line as well. Here there is a little bit different, like for each and for, there is some difference. But look that almost everything else is pretty much the same. Because there are some languages, C# was created, target like Java users, C users. So is that why they look so much? Kotlin and Python is kind of the same. Kotlin was created on top of Java, but has a lot of Python and C# thing. So what I'm trying to show you here is that once we know the algorithm, translate to a program language is not that hard. As long as you know the rules, we can look the rules and build that. Now let's see a different language called assembly. That is a very low level language and is not still machine code, but you say that is almost there. So this is that same algorithm implemented in assembly. Look, that is not that easy to read. You need to understand way more. So is that why coding assembly is not that easy? Back in the days, assembly was the only, I say not the only, but the major language to build anything. Still today, there is some segment of the market that they use assembly a lot. But most of the coding that we talk, that we see the media, that we apply for job is not in assembly. So as you can see, language has different level of abstraction. All those languages like Python, Kotlin, C# and Java, they are considered like fourth generation or high level language because they are closer to English. Assembly, no, it's very low level and is a different beast. I'm not an assembly like coder. Here I have to ask someone to, okay, having this code in C#, could you prepare a code in assembly for me? So I cannot even guarantee that this is working fine, but I think it is. There is some comments here that is going to help us to understand, but see that is not that easy. And now is the most interesting thing. This is the code that the computer can execute. Look, all those are instructions that we're going to understand in a next class, kind of, what this could mean, but this is what a computer can execute. And remember, 0 and 1 is just an abstraction. This has to be in a specific format, it has to be loaded, and the computer can execute. What I'm trying to show you is that look how different the same solution or the same idea to solve something can be different on the level. So this is for human. We have the flexibility to just explain something. Could even be image. Those are like high-level programming language. This is a low-level programming language, and this is machine language. So I never had a professional opportunity to code direct machine language. I don't know no one that did, but people does. I never worked with doing assembly. I did some course, read some review, just to understand, but I didn't fall in love. It's not what I like to do. It's not this level of coding. Where I fall in love was language at this level, because I could really understand, express, and build solution on top of that. Those is very specific, but below all coding, this is where we go. However, there are tools that we translate from this to this. So we don't need to care about. So in computer science, there is some disciplines like compilers that they learn how to do this, how we get this and go there. So it's not our focus here. We'll be learning how to drive a car, not how to build a car. That is the idea. Okay, so this was our first class. The idea is just to set the tone, explain a little bit, and then give this example about what algorithm is and what kind of thing we're going to be learning. So program basically is to automate things. And we'll practice a lot, like our problem solving skills. And I hope you enjoy it. And let's see, this is the first one. So every Tuesday and Thursday. If I see that people is joined at the same time, I will try to be on clock. If not, I can do in other time, adjust to my schedule. Okay, so have a nice day. See you next class. Oops, here first.